Okay, so we are going to be working through how to solve an indefinite integral together. So I have this function here. The function of x equals x cubed plus the cubed root of x plus 12 plus 1 over x cubed. So to write it in our integral, we would put our function inside. So that's x cubed plus the cubed root of x plus 12 plus 1 over x cubed, and then dx. And we're using dx because that is the variable of integration because our function is in terms of x. So I'm going to focus on each part by itself. So let's look at our x cubed. So to find the integral of x cubed, you'll have your base x, and we know that we have to add 1 to our power, so we're going to add 1 to that. So that's going to be x to the 4th. However, we can't just leave it as x to the 4th, because if we took the derivative of x to the 4th, you would actually get 4x cubed. And we don't have that here. That's not what this function is. So we need to divide by 1 over 4. So if we took the derivative of that, we would have x cubed and then 4 over 4, which would cancel each other out. So for x cubed, the derivative of that is 1/4 x to the 4th. So let's now look at this cubed root of x. So the cubed root of x can also be written as a fraction of x to the 1/3, just like the square root of x is x to the 1/2. So if we take the integral of that, x to the 1/3 would need to have 1 added to that, which when we're adding fractions, we usually put the bases at the denominators the same, so 1/3 plus 3 over 3. So we would get this x to the 4 over 3 power. Now again, we can't just leave the coefficient as 1, because if we were to take this derivative, it would have been 4/3 x to the 1/3. We don't have that as our original function up here. We have to remember to divide 1 over whatever our new power is. So 1 over 4 over 3, which is also the same thing as 3 over 4. Which, if you take the derivative of this, you're going to get 3 over 4 times 4 over 3 x to the 1/3, and you can see that these cancel. Make sure we add our plus signs there. So now we're going to move on to the next term, which is this plus 12. So it's important to remember that we have this x to the 0 power here, because x to the 0 is 1. So if we were to add our power, we would have x to the 0 plus 1, and then we'd still have this 12 here. So we would be left with x to the 1st times 12. Now, you may be wondering, do we have to do this like 1 over our new power? Which we could, and we technically are, but 1 over our new power is just 1. So we're left with, at the end, 12x to the 1st power. So now we're going to look at this very last part, this 1 over x cubed. And remember that the 1 over x cubed can also be x to the negative 3 power. So then we're going to treat it just like we have all the others. We're going to do x to the negative 3 plus 1, which ends up being x to the negative 2. And we have to do 1 over our new power, so 1 over negative 2, or negative 1/2. And we aren't quite done, because we do not know what that constant, if there was a constant in our original function, we have to add this constant of integration, this plus c. So it would take care of any and every case of this function. So our original function was f of x, and now we have this capital F of x equals 1/4 x to the 4th plus 3/4 x to the 4/3 plus 12x to the 1st, which could also just be 12 to the x. Sorry, 12 times x, and then minus 1/2 x to the negative 2 plus c. And a great way to check your work is to take the derivative of your new function and see, can we get our original function back? So let's get here a new color. So the derivative of f of x would be 1/4 times 4 x cubed plus 3/4 times 4 over 3 x to the 1/3 plus 12 times that 1 x to the 0 minus 1/2 times negative 2 x to the negative 3. And then that plus z would be a plus 0. So simplifying this, we get x cubed plus x to the 1/3 plus 12 plus, these cancel out, we get plus 1x to the negative 3, which is exactly what we have if you were to rewrite some of these. So x to the 1/3 is the cubed root of x plus 12 plus x to the negative 3 would be x 1 over x cubed, and then we would have this x cubed up top, which is exactly what our original function is. And so that's a great way to double check if your work is done correctly. So this is the step-by-step how to solve an indefinite integral.